friends, in this video we will see how we can use analog signals at PLC inputs/outputs. After a short introduction, I will explain some points of hardware configuration and programming related to analog signals in the TIA. Up until now, we have done many projects with digital inputs/outputs. At the beginning of this tutorial course, I explained the PLC hardware and its wiring schematic. We know the digital sensors or push buttons have two states, on or off, open or close. These instruments use 0 and 24-volt DC to send their on-off states to the PLCs. Also, we could use 0 or 24 volts DC to turn on/off a digital output such as this signal lamp. On the other side, there are many devices such as these two flow meter and level transmitters or some actuators which are using analog signals to transmit or receive data. For example, a voltage between 0 to 10 volts. To store and use these signals in a PLC program, we usually need more than 1 bit, usually 16 bits. Let's see an example. Suppose we have a level transmitter to measure the level of a substance such as water. This transmitter can be tuned to generate a voltage from 0 to 10 volts when the substance level is between 0 to 50 meters. PLC can receive this signal. See here, this is the S7-1200 programmable controller manual of Siemens company. In this manual, we can find the technical data related to the S7-1200 CPU. This is a diagram of CPU wiring. As you see, the CPU supports two analog inputs. Now pay attention to this table. It shows the measurement ranges of the analog inputs for voltage signals. Based on this table, negative values are not supported. For 0 voltage, the CPU generates a 0, and for 10 volts, it generates this number 6C00 in hexadecimal form, which is equivalent to 27,648. Also, if we receive this number at the program, it means this voltage has appeared at the PLC input. So in my program, I will have these numbers. Now I am going to write a function to show the substance level, which is a number from 0 to 50 meters based on the received analog signal. Let's create a new project. Here, click on the Configure a device item to define the PLC station. This is my CPU. Now let me select my CPU to see its details at the bottom. As you can see, my CPU supports 8 digital inputs, 6 digital outputs, and 2 analog inputs which are named channel 0 and channel 1. For example, this is the address of channel 0, IW64 or IW64. So this channel uses 16 bits of the input image memory of my PLC. It just supports voltage signals from 0 to 10 volts. Now let's write a function to use this channel. Click on Add New Block. As you know, we use the functions without any memory. Also, we have seen how to use a data block to store data. If we need a function with a memory, we must select a function block item. Now let me have a short explanation of the organization blocks. Until now, we started our programming from the main block, OB1. The OB1 block is executed cyclically and it is the main block of the PLC program. This is where you place the instructions that control your application and call additional user blocks. As you can see, here is a list of the other organization blocks. For example, a startup OB will execute one time when the operating mode of the PLC changes from a stop mode to a run mode. After the completion of the main block, OB1 will begin executing. The time of day OB is started either once a specific time or periodically. Okay, let's continue. Let's select the function and write a suitable name. Alright, the first input of this function is from the analog input channel. For 0 to 10 volts, this channel gives me an integer number from 0 to 6C00 based on the hexadecimal format. The next inputs are the lower and upper values of the level sensor measurement, which are 0 to 50 meters for this project. Here I define two outputs. The first one will show the level of the substance and the next one is the error output, which it checks the range of the measurement. Also, let me define an internal memory to use it in my program. Okay, at the first network, I am going to use the out range instruction to activate the error output. If the input measurement is not between 0 and 27,648, the error output will be on since the measurement value is out of its rated range. At the second network, I use the norm instruction to convert the measurement to a real number between 0 and 1. Now I am going to use the scale instruction to convert the previous result to a number between 0 to 50 meters. I assign these numbers as the lower and upper values, which are defined as the function inputs. Now let me use this function in the main block OB1. Alright, first I write the analog input address. Then I define 0 and 50 as my desired range. At the output, I can use PLC memory to store the function results. Let's extend this program. Alright, we are going to learn how an analog output module can be defined and used in the TIA. Then we are going to turn on an electrical valve with a 16 milliamps if the level is less than 5 meters. My CPU does not have any analog outputs, so I need to modify my hardware in TIA software. So I click on Device Configuration and find the analog output module from the right list. As you can see, the inserted module supports voltage and current signals. I need a current signal from 4 to 20 milliamps. This address QW96 is the address of my first analog output. Before starting the programming steps, let's find the measuring range table of the inserted analog module. As you can see, to have 4 and 20 milliamps, I need to send 0 and 27648 to the output address. To have 16 milliamp, I need to send this number. Now let's start the programming steps. Alright, at the second network, if the level tag is less than 5, then the move instruction sends the number 27648 to the analog output. Otherwise, it will be 0 to have 4 milliamps at the output. Let's test this program with the sim table. Alright, this is my program and this is my function. Here pay attention to insert min and max values correctly. Now let's test the program with the sim table. These are used tags in my program: level sensor, electrical valve, level, and error. As you can see, when the level is less than 5, the electrical valve is on with this number. Also, when the level is greater than 50, my program activates the error tag. Now let's test the previous function with a real analog input. Here I have used IW66 as the analog input address. Pay attention to my CPU, which supports 2 analog input channels. My analog input addresses are IW64 and IW66. I have used the second analog input in my program, which receives a voltage between 0 to 10 VDC. Here there are my 2 analog input connections. The second one is connected to this potentiometer. So this function receives the analog input and converts it to a number between 0 to 10 volt DC. So the function output shows the voltage at the analog input. Note that by using the potentiometer, I can change the voltage at the analog input and show its value at the function output. Also, like in the previous simulation, when the input voltage exceeds 10 volts, the second output, the error message, is activated. At the bottom, I have written a simple program to test my analog output. With this program, I can transfer 3 numbers to my analog output address, which makes the PLC to produce a voltage on the selected analog output channel. As you can see, my analog output module gives me 2 analog outputs. I have used its first analog output, which its address is QW96. I have connected the analog output to this voltmeter to show its voltage. Alright, with these 3 contacts, I can transfer 3 numbers to the analog output, which based on the Siemens documents will produce 10, 7.5 and 0 volts at my analog output. Let's test them. Pay close attention now. 2 contacts are activated. So based on the program, first the CPU generates 7.5 volts at the output, but at the next line it changes its measurement value and transfers 0 to the output. So when the second and third switches are activated, the analog output will be 0 volts. Now we are going to do another project using the factory I/O software. Alright, This is the tank that I used it before. Here is a potentiometer that gives us a voltage between -5 to 5 volts and an electrical valve that can be controlled with a voltage between 0 to 10 volts. Also, the tank has a level meter which gives us a voltage up to 10 volts when the liquid level is 3 meters. Finally, this is a digital LED display that receives and displays integer numbers. All of these devices are analog. In this project, we will see how the potentiometers can send their voltage to the PLC and also how the PLC converts that to a voltage between 0 to 10 volts to control the fill valve. We will see how the PLC can get the level meter voltage and show the liquid level on a digital LED display. First, let's design the plant in the factory I/O. Let's insert a tank and check if it is in analog mode or not. Here is the fill valve, which works with a voltage between 0 to 10 volts. This level meter measures the liquid level. When the liquid level is 3 meters, the level meter outputs 10 volt DC. Now we need a control box. As you know, for vertical movement, press the V key on the keyboard. Now let's insert a potentiometer and a digital LED display. Well, we can change the potentiometer's voltage range. Select the third range, -5 to 5 volts. Now let's modify its name. Now right-click on the digital display. As you can see, it can be used to show voltage ranges or an integer number. Let's select the integer mode. Now let's modify its name. Now let's click on the File menu and select Drivers to set the PLC connection settings. We're going to use the Siemens S7 PLC simulator. Naturally, we don't need these digital inputs, outputs. Click here to configure the PLC. Let's select the word type for the PLC analog inputs, outputs. Here in the first column, we determine start addresses, and in the second column, we select how many inputs or outputs we need. Let's write 0 here because we don't need any digital input-outputs. Finally, we need 2 analog inputs and 2 analog outputs and define the number 10 for their start addresses. So we need a PLC with 2 analog inputs, outputs. Now let's connect the potentiometer and the level sensor to the PLC inputs. Here, 2 IW10 and IW12 addresses are used for these analog inputs. At the output part, let's use the fill valve and the digital LED display. We have completed our plant using the factory I/O. Now let's configure desired PLC on the TIA. Let's insert an analog input module. Let's change the start addresses of the inserted module. Here I define 10, like to the PLC settings in the factory I/O. As you can see, now we have 4 analog inputs. The plant needs the 2 inputs with the IW10 and IW12 addresses. Similarly, let's insert an analog output module and modify its address. Alright, let's define suitable tags for the analog input-outputs. This tag is used for the potentiometer which is connected to the PLC input with the IW10 address. Similarly, let's define a suitable tag for the next analog input. Now we must determine the input type of the inserted analog module. The signal on the first input comes from the potentiometer. If you remember, the potentiometer voltage is -5 to 5 volts and the level meter voltage starts from 0 to 10. The first analog output, which is connected to the fill valve, is controlled by a voltage between 0 to 10 VDC. The last output is used to send an integer number directly to the digital LED display in the factory I/O. it doesn't need to determine its voltage range. Now let's complete the PLC tags table. Now let me explain the PLC program. The norm and scales are the main instructions. First, the potentiometer sends a voltage from -5 to 5 volts to the first analog input. Based on the S7-1200 manual and this table, if the received voltages are within the rated range, we will have a number from -27,648 to 27,648. Then the norm instruction converts the received number from the analog input address to a number between 0 and 1. After that, the first scale instruction converts that to a number between -5 to 5, which represents the received voltage from the potentiometer at the PLC input. The second scale instruction converts it to a number from 0 to 27,648. This number will be sent to the first analog output. So based on the S7-1200 manual, the analog output module will generate a voltage of 0 to 10 volts to close or open the fill valve. This is the PLC program. Similarly, norm and scale instructions are used to convert the level sensor signal to a number between 0 and 300, which represents the liquid level on the digital display. Let's transfer this program to a virtual PLC. Now let's link the factory I/O to the virtual PLC. And now let's test the PLC program which is linked to this tank. Let's select the fill valve and this potentiometer. As you can see, when the potentiometer is 0, middle of the -5 and 5 volts, then the fill valve has 5 volts, which is in the middle range of 0 and 10. If I change the potentiometer voltage to -5 volts, the fill valve will be closed. Pay attention, it seems to me that there is a problem. The fill valve is switching between two values. As you can see in the PLC program, the analog values are switching between two values as well. Why? Let's check the hardware configuration. Because of my simulation, my CPU reads its analog inputs from the inserted module and the factory I/O. So the CPU is reading its analog inputs from two sources. We only want to use the factory I/O. So to resolve this problem, let's delete this module to limit the CPU input source to only the factory I/O. Now let's transfer the modified PLC hardware. The problem is resolved now. I can change the fill valve voltage with the potentiometer without any issue. Also, the digital display shows the liquid level. Again, let's change the potentiometer voltage from here. Well, we must exit from the forced state. Alright, as you see, I can control the fill valve with this potentiometer. Similarly, I can link the factory I/O to my PLC and test the program with a real potentiometer. I have connected the analog output to this voltmeter to view its voltage. As you can see, based on my program, I can use the potentiometer to change the analog output voltage and to control the filling valve as well. Now let me close the filling valve. I hope you have learned how we can use analog signals in industrial processes. Alright, until now we have explained basic instructions and some abilities of the TIA to program a PLC. Also, we have seen how a PLC connects to computers or electrical instruments. In the next videos, we will learn how to use the TIA software to configure, link, and program an HMI or Human Machine Interface display panel. Thank you for watching this video. See you in the next one.